Alright, this lesson is about adding and subtracting rational expressions that do not have like denominators already. This is part one. Okay, we need like denominators in order to add fractions. So the left side has 2 in the denominator. The right side does not have a 2. So we are going to place a 2 in the denominator and the numerator. That way we are really multiplying by 1 because 2 over 2 is 1. Now the right denominator has a 3. The left denominator doesn't, so we'll do a 3 in the bottom and the top. So essentially they're both 6's now. But the right denominator has a y, so I give the left denominator a y. Got to do the same thing to the top. Okay, so now I have a common denominator. Once you have a common denominator, you can make one fraction out of it. So my common denominator is 6y. Okay, both of these are 6y. Now, as far as the numerator goes, we have here 9xy minus, okay, because the minus sign, 6x. And I'm looking here for the common factor. Okay, a common factor. Essentially, this is what I'm looking for. If there's something that is common to all three terms, all three, then I can divide. Okay? So is there something that's common to all three of these terms? Back in the day when I used to simplify the end of a quadratic formula problem, I would put a heart around things to remind me that I needed to do all three or nothing. This, and this. Now all three of these are divisible by 3. So I am going to divide all three of these by 3 to get my final answer. So my final answer is going to be 3xy minus 2x divided by 2y. Okay? So that is the final answer for number 1. Alright, let's look at number 2. Now we've got a 2 in both denominators. Now, in alphabetical order, the first variable is uv. So the right side has a u, the left denominator does not. So I'll give it a u, got to do it in the top and the bottom. Now the right side has v squared. Okay, this side only has a v. So to make this a v squared, I need to multiply by another v. Okay, so I'm going to multiply by another v, and I've got to do that in the top and the bottom. So now, looking at these two, that's really v squared, just like that. So we do have like denominators at this point. Alright, my like denominators are 2uv squared. So I can combine these into one and do my 2uv squared common denominator. Now in my numerator I have 4uv plus 5u. Now, do you see anything that's common to all three terms? Okay, if you do, it's like you're hearting it. All three, this, and this. It's like the 3 parts of the heart, alright? The 2, ventricles and the bottom part here. They all share a u. U. So they have u in common. So I could divide all 3 terms by u. And if I do that, I'm going to get my final answer. Okay, so that's going to give me a final answer of 4v plus 5 divided by 2v squared. Alright, I divided everything by u. Now, here's another way to think about it. Alright, some people won't prefer the way I just did by dividing everything by u. That won't make sense. Alright, so here's an alternative way of looking at it. GCF. Okay, if you look at the numerator, we're always looking and asking ourselves, what's the greatest common factor of things? Here, u is the GCF, so you could think of it this way. Pull out that u, and then what's left behind? So if I pull out that u, then I've got 4v, well, let me use a different color. If I pull out that u, then I've got 4v plus 5 left on the inside. Meanwhile, in the denominator, I have 2uv squared. Alright? I colored them both green to make it obvious that I have a u in the numerator and a u in the denominator. So since this is all multiplication, this is connected by multiplication, I'm allowed to cancel these u's out. So you can think of it as dividing this u by this u. Those are canceling out, and that is going to then leave you with your answer, 4v plus 5 over 2v squared. Alright, so if you prefer to think of it as pulling out the GCF and canceling out, think of it that way, whichever way resonates best with your brain frequency. And we all have a different brain frequency. Anyway, keep going. I have the 3 and the 5. This has the 5 that this does not have. So I'll give this a 5. Got to do it in the top and the bottom. The left side has a 3. This one doesn't have a 3. Okay, so I've got to give it 1. So I give it a 3. Got to do it in the top and the bottom. This side has an x. This side doesn't have an x. So I got to do an x in the top and the bottom. So now they are essentially both 15x. 15x. So I can put them together. Okay, so if I put them together, I have a common denominator of 15x. Now the numerator here, I have 5 times 5, so that's 25x, okay, minus 6x squared. Okay, so one way to think of it is all of these have x in common, x, x, x. So one way to look at it is dividing all 3 of these, and it has to be all 3 or nothing. You could look at it as dividing all of these by x. Alright, so that's going to cancel out 1x from each term. So that's going to give you 25 minus 6x over 15. Alright, I just took away or canceled out 1x from each of these terms. Alright, this had 2 of them, so it still has 1 left. Okay, that's one way to think about it. There is no other common factor between all 3. Alright, notice I can't divide the 25 and the 15. Alright, this is connected by subtraction. So I can't do the 15 and the 25. I can't divide these by 5. And I can't do the 6 and the 15 either, even though these are both divisible by 3. Okay? Because it's connected by subtraction. You can only do all 3 or nothing. You can't just do 2 at a time. The other way to think about it is GCF. I could look at this as, oh look, the numerator has a GCF of x. So I can pull out that x. Alright, that's going to leave behind 25 minus 6x over 15x. And see, now the x I just pulled out and the x in the denominator, they can cancel out. It's hard to cancel out an x. Okay, these x's can cancel out, and that will just leave you with 25 minus 6x over 15, which is what we had before. Alright, you decide which way is the best way for you to think about it. Okay, let's go again, shall we? This side has a 4, this side doesn't. So I'll give it a 4, top and bottom. This side has a y. Well, let me do the 3 first. This side has a 3, This side doesn't have a 3. Now it has a 3. This side has a y. So now the left side has a y. Now they both have a common denominator of 12y. 12y. So I can put them together. 12y. Now here I've got 24y plus 6x. Do all three terms have something in common? It has to be all three, not just two. Okay? The greatest common factor of all of these is actually 6. Alright? All of these are divisible by 6. Now you could have said 2 or you could have said 3. But the greatest common factor is 6. So let's do that. So if we divide all of these by 6, that's going to give us our final answer. Okay, that will give us our final answer of, 24 divided by 6 is 4. So 4y plus x over 2y. So that's the final answer. Alright, for me that's the easiest way to think of it, is dividing all of the terms by 6. But just one more time, that I could have looked at it as GCF, right? Looking just at the numerator, the GCF is 6. So I could have done 6 and then 4y plus x over 12y. Okay, but then you could look at the 6 and the 12 and go, okay, let's divide these both by 6. Alright, 6 divided by 6, that cancels out, leaving 4y plus x, which is what we had. 12 divided by 6 is 2, leaving 2y. To me, it was easier to just divide everything by 6. One step. One and done. Okay? So, let's go again. They both have a 5, so I don't need to mess with that. This side has an x squared, this side doesn't. X squared, top and bottom. This side has a y, and this side has y squared. So I need to multiply by another y to make it y squared. Now, both sides have 5x squared, y squared. 5x squared, y squared. That is my common denominator. So 5x squared, y squared. In the numerator, I have 3y plus 6x squared. Do you see anything common to all three factors? No. Looking at the numbers, 3, 6, 5, there's no common factor there. Looking at the variables, they don't all have y's and they don't all have x's. So that means this is the final answer. Okay, if you looked at it as a GCF, you might have pulled out the 3 and had 3y plus 2x squared over 5x squared, y squared. But then there's nothing you can do with the 3. It doesn't cancel anyway. So you might as well have left it as a previous step. You know, if you did pull out the 3 and you have this, you know, I would accept that as well as an answer. I don't think there's anything wrong with that. Alright. Looky here. This side has a 4. This only has a 2. So if I multiply by 2, now it's a 4. Great. Got to do it to the top. This side has an x. This doesn't. Got to do it in the top and the bottom. This has y squared. This doesn't. Got to do it in the top and bottom. Now both denominators are 4xy squared. 4xy squared. So I can put them together. 4xy squared. So in the numerator here I have 10x squared, alright, x times x, and y squared, minus, because of that, 6y. Now, is there anything common to all three? Yes. They both are divisible by 2, so they have that in common, but they also share a y. So the GCF of all three terms is 2y. Okay, so I could think of it this way. Alright, I'm dividing all three terms by 2y. That's one way to think about it. Okay, if I do that, so dividing 10 by 2 gives me the 5, and I'm also canceling out one of the y's. So, wait, I didn't mean to put y. Alright, I've got the 5. Nothing's happening to the x's, so I'm going to have x squared. One of these y's is going to cancel out because I'm dividing by y. So it'll just be 5x squared y. Now here I'm doing 6 divided by 2 is 3, and then y divided by y, they cancel out. Okay, 4 divided by 2 is 2. Nothing's happening with the x's. There's no x's I'm dividing by. But one of the y's is being canceled out. So this will just leave one extra y. So this is the final answer. Right here. Kabam. Okay. Let's see. If you wanted to look at that as a GCF situation, then you would have gone, what would you have gone? Yeah, the 2y. So you would have pulled out 2y like this. And you would have said, okay, 5x squared y minus 3. Alright? Over 4xy squared. And then you would have canceled the 2 with the 4. Alright, something like this. You would have divided by 2 like this, and the y's, you know, the y would have canceled out a y, and eventually you would have gotten this. Alright, I think the way I did it the first time is more efficient. Anyways, see how many problems are in this. Okay, 2 more. 2 more for this video, and then we'll cut it and make another video. They both have 2's, but this side needs a to the 3rd power. Got to put it in the top and the bottom. Now they're the same. 2a to the 3rd power, 2a to the 3rd power. Time to put them together as one. So there's my 2a to the 3rd power. Now, so I've got 2a to the 3rd power b, always go alphabetical order, plus 5a. Now, do you see anything that all three terms have in common? They all have an a. So I would look at it this way. Let's divide all three. It's got to be all three or nothing. Let's divide all three by a. That means each term is going to lose an a. Okay, so if I do that, do I have room down here? I'll put it off to the side. If I do that, then this will become 2a squared. Alright, it's going down by 1. B plus just 5, because the a cancels out. Alright, it goes down by 1. Over 2a squared goes down by 1, because I'm dividing by a. So that's it. That's the final answer. Okay, look at number 8. Let's see, got to make them the same. Alright, if I multiply this by 2, it'll be a 4. Got to do it in the top and the bottom. Alright, did I do that on the last problem? Top and bottom, yeah. Here I need x squared, so I need to multiply by x. Now it's x squared. Got to do it in the top and the bottom. So now they have the common denominator. They are both 4x squared. 4x squared. So I can put 4x squared here. Now here I have 6x. So it's 6x minus 3. Now, do you see anything common to all three terms? Yeah, all three terms, nothing. No, I take it back. Nothing's common to all three terms. I don't know what I was thinking for a second. But I returned to my sanity. There is no common factor among all three terms. So that means this is the final answer. And I cannot divide these by 2. I cannot cancel out x's. This is connected by subtraction. Alright, unless you can divide something by all three, forget about it. Alright, and that is the end of this page, which is a good place to stop this video. So this will be the end of part 1, but we have more to come in part 2. I will see you on the next video.